I will now talk about two new nodes that, although they are used for several things, their main purpose, or the main thing that I will be using it for, is to fix the fracturing in transparent objects. So let me show you an example. I have pre-fractured this diamond and I have rendered it with and without fracturing. This frame is without the fracturing applied, and the next frame is with the fracturing applied. So here you will notice that we can see the interior faces, and this is causing a lot of inner reflections and inner refractions. And of course this doesn't look right, especially if you have an animation where you have the complete diamond and then you're going to shatter it or break it somehow. So let me show you the final animation and what I would like to achieve. So if I hit play here, you'll notice how as the diamond falls, it looks complete. You won't see the interior faces, but once it starts breaking, so here on this first frame where it breaks, you can start seeing the interior faces, and as it continues breaking, the new faces will start being visible. So this is a very useful tool. Of course, you could do this before, mainly with compositing tricks or with animation. You could animate the position or the visibility of the geometry, or even what I used to do was in comp, I would render two passes, one with the shattering and one without the shattering, and you could just switch them at the right time. But this will help us to do everything within the Houdini environment without additional keyframing or custom tricks. So let me minimize this. And I have gone ahead and created a series of points just to shatter the point of the diamond. And I will connect this to the RBD material fracture node. I may need to change this to concrete. I could also use glass, but just to show you, it doesn't really matter if you're using glass or wood or concrete. The technique will work regardless of the material type you're using. So let me again hide the rest of the objects. Go to my RBD exploded view. And here are my new shards. These are the new pieces that are being generated. And if we tried rendering this, let me go to the render view, select my camera, and I have already created a mantra node. So if you go to the output, this is a mantra node that will be rendering the scene. So of course I won't wait for the scene to render. It's taking quite some time to render. This is why sorry, I have the examples here pre-rendered. So this is what you're going to get once the diamond is fractured. So if we turn off this node, you'll get the complete diamond, just as we saw here. So what I'm going to do to fix this, and actually I'm going to change to a wireframe. Again, I'm going to turn on the RBD material fracture node. And I will probably change to my other scattered points just to generate more pieces. So here you can see the interior pieces that are causing this rendering trouble. So let me real quick create an RBD simulation. This is something that we will talk about in volume 2 of this series, but let me for now just make a quick test. Type RBD solver, and I will connect my RBD material fracture node to the solver. Now within the solver, I will turn on the ground plane. and just hit play. Now it's creating some constraints. I don't really need the constraints, so I will just disconnect port 2 and 3. And there we have a quick test simulation. Okay, so I'm going to add on RBD disconnect faces node, and I will also add on RBD connected faces node. So these nodes work together. First of all, I need to plug in the RBD connected faces, and this will generate the list of faces that are being created, and it will assign them an attribute called face ID. It will also create an attribute called primDist that is measuring the distance or the position between each of these faces and the distance between them. So let me show you in a more practical way. It's easier if I show you here with the example. I will simulate a few frames, and if I go to my geometry spreadsheet and click here on the primitives, you will notice that now we have this face ID and the distance. Actually, I accidentally changed the name, so I will control and middle click this distance attribute to revert it to the default name. So here we have the primDist, which is the distance between each primitives, and the value will be very, very low. Most of them will be 0. Actually, all of them are 0. These are very, very low values. And now we can go back to the scene view, and I will connect the RBD disconnected faces after the simulation. So notice how by default nothing really happens, at least apparently. What this node is doing is it's creating an attribute called disconnected. So again, let's go back to our spreadsheet, and here under the primitives you will notice we have this new attribute called disconnected, and on frame 16 all of the primitives have a value of 1. If I go back to frame 1, notice how most of them have a value of 0. Not all of them, but most of them. And if we take a look at our geometry here, we could change the mode to delete disconnected. Delete connected. So rather than just creating the attribute, we are literally deleting the interior faces altogether. So let's try playing the simulation. And notice how the faces, the interior faces, will immediately appear when they are separated more than this distance, which the default value is very, very low. So the moment they start separating from each other, the interior faces will appear. We could try increasing this value, and you'll notice how now we cannot see most of them. But usually you want to keep this very low value. So this is how this animation was generated. I'm just using the default value, and the moment it starts breaking, the interior faces will appear and will be rendered. So again, here we cannot see the faces. In frame 9 there was a contact. Let me go back to my custom points. So here the lower pieces are starting to break. Let me reduce this threshold. Actually increase it, sorry. So here we only see the lower pieces being displayed. And as the upper pieces start to separate, the inner faces will start to appear again. So although this technique is very useful for rendering transparent objects, you can also use these attributes that are being generated to create some effects. For example, we could change the mode to create attribute, and probably when we have a disconnection between these pieces, we could generate some debris or particles, or even create a fluid simulation with these flagged primitives.